Hello and welcome to space. Now, believe it or not, there's a link between the bedbugs in your hotel room and the Philae lander, and between geothermal energy and the Smart 1 moon mission. We're with the entrepreneurs who are taking space tech down to Earth. But first, some more news from the universe this month. Sentinel-2A, the second of Europe's Copernicus satellites, is now finished and set for launch in June. It will offer a new view of changes in land use and vegetation. NASA scientists have developed a concept to send a submarine to explore the liquid methane and ethane lakes of Saturn's largest moon, Titan. And astronomers admit they're baffled by this 250-kilometre plume in the atmosphere of Mars. Nobody has a good explanation for what it is. To our main story now, and we're here in Spain and in the UK to meet some real-life space tech entrepreneurs. Our first rendezvous is in a field near Barcelona, with a startup whose products are quite literally taking off.
This is our drone that we made ourselves, and it uses space technology for autonomous navigation.
The autonomous drones use an enhanced version of GPS with accuracy down to 2 centimetres. One business line is to use them to monitor large crop fields.
Today we're going to do a flight. Firstly, a manual flight to test the gimbal, because we're using it for the first time, and then we'll do an autonomous flight as well.
When they're not flying, the drone engineers are at ESA's Barcelona Business Incubation Centre, one of 11 around Europe. Here, startups are given advice, office space and €50,000 for technology investments. But first, they must show they have a viable space tech business.
What we do is we basically evaluate two things. First, the requirement of using the space technology into a new innovative product or service. And secondly, is actually evaluating the business plan.
Also at this centre, managed by Barcelona Activa, is a firm using satellite services in a very different way. They develop broadband, internet and VoIP systems, including a service for shipping.
The innovation that we've developed at the ESA BIC here in Barcelona is that any boat can use an internet and telephone connection as they do on land.
Their tech is all about using much less satellite bandwidth than other systems for the same result.
I could talk to you about a concrete example of a mega yacht in the Caribbean that allows a client to receive a German phone number and a Canadian phone number in order for him to be able to reach his clients and do business.
We head now to Harwell near Oxford to meet startups inspired by Philae, by astronauts and by a recent moon mission. The ESA Business Incubation Unit here supported Taff Morgan as he took science knowledge from his work on the Philae lander to develop a system that hunts for the chemical signature of bedbugs.
Last year we landed on a comet. We built a small instrument called Ptolemy, a shoebox-sized chemistry laboratory. We're now translating that to the hospitality industry globally, and particularly we're looking at measuring these little blighters, bedbugs, in hotels. So we will sample with our device, and all we do is we suck the air from the tube. It's exactly the same as what we did on Philae. We sniffed the atmosphere, we trapped it onto an oven, and then we put it through into the mass spectrometer system, and we did the analysis.
Another Harwell innovation is drawn from space research done 50 years ago, now developed into a heart and health monitoring device.
This is a new way of measuring the electrical activity of the heart. Now we're going to combine it with acoustic monitoring, temperature monitoring, and this accelerometry, which is just general movement when you're walking around. It comes from a NASA innovation in the late 1960s, which they wanted to monitor the heart activity of astronauts up in space.
Space missions push the boundaries of what's possible in engineering, and that know-how can be reapplied elsewhere. This two-man startup are graduates of the Business Incubation Centre. They've made a cutting-edge nanomaterial coating for heat exchangers.
Our innovation comes from some work done on an ESA mission about 10 years ago, a Smart One, with a coatings technology, and we managed to transfer that into an ability to create a nanostructure which has fantastic properties on energy transfer, which 300–400% faster energy transfer through a surface.
That technology could be used again in future space missions, and this year it's due to be tested by a geothermal energy lab in Germany.
We can put this on very, very complex structures. We can put it on pipes, we can put it in grooves, we can even put it in the center of a heat exchanger with a very, very complex surface. Now that is a real breakthrough because that allows you to make heat transfer equipment a lot smaller, a lot lighter, and a lot more efficient.
Of course, turning a technology for spacecraft into a business on Earth isn't straightforward.
The main trick is actually help the company to become a business. Because in the beginning, they normally begin with something that is very technical or very scientific, so they have to get down to actually have a really real business plan that will work.
While they're here, the startups also take advantage of the environment to make connections.
Estamos en un hub.
We're in a hub where there are lots of companies developing products linked to space. We have in the office across the corridor a company that works in satellite telecommunications, and we, who want to improve our communications, can work with them. So the networking that it gives us is one of the key points about being here.
So far, around 200 companies have been through the ESA Business Incubation Centres around Europe. Now, to the second episode of our new series, The Astronaut Academy. And Thomas and Andreas are quite literally getting to grips with the Columbus module of the ISS.
Hi, I'm Thomas Pesquet, and today I'm training on the European Laboratory Columbus on board the International Space Station. Will be specialists responsible for whatever happens here in Columbus, so it implies knowing the very guts of the laboratory.
As soon as they progress in their training, we'll start adding malfunctions so that they are prepared to any possible contingency.
You need to be a good handyman if you want to be a good astronaut as well.
In case there is a meteoroid that is hitting the shell, they have to be able to remove all the wrecks in the module and be able to find where the hole is and repair it.
I'm a big optimist, and we don't think about what could be wrong. We train for it, and if it happens, we'll be ready.
That's it for now. Next month, we take a close look at the science of the Rosetta mission. See you then.